Okay, wait a minute. I need to turn this up. Hello, hello, hello. Okay. Alright, guys, sorry I haven't posted in like 2 or 3 days or something. I know it's been a while since I last posted. Obviously, the past week has been crazy for a lot of different reasons, but whatever. I'm not going to go into that. But I have been working on the Space Adventures game, and I've come to a point where I think I'm kind of just done with it for right now. Like I said in the last video, our school was participating in competitive programming this semester, and I wanted to try and participate in that. So I need to start doing stuff like leak code and math and things to prepare for that. So I decided to kind of put a nail in the coffin on this project for right now. I definitely want to come back to it and improve it a little more. But as you can see on my walk of time right here, I spent almost 30 hours on this, and I used to show you like how much is AI code. I don't know where to see that, honestly. Okay, I guess you can. It says green is human additions and red is human deletions, so you can see there's very little to almost no AI code. I'm not saying I didn't use AI at all, but I didn't use AI to write my code. I did use AI to search things up. But I did want to kind of go over like where I got with this project and kind of some decisions I made, some of the things I learned. It's definitely not good code. It's quite bad code, actually. But I thought it might be interesting to give you guys a recap of all I did. And if you guys learned something from it, I guess that'd be cool too. But thank you all for watching, as always, and all the great and supportive comments. It really does mean a lot. And I'll try and post more consistently. I did miss the past couple days, and I do not feel great about that, but whatever. Anyways, this is how the game currently looks like. This project is public if you want to go look at all the code, but like I said, it's not good code, so yeah, to look at it with caution. So yeah, here's the game. See, it's not that polished, kind of all over the place. I definitely need it to be more narrow and there'd be less enemies. There's no sound or anything. It's just completely silent, but yeah, that's how the game looks. I drew all the art myself, and I coded it all myself, but obviously it doesn't look good, but I don't think that was the point. I learned a lot about Pygame, learned a lot about building products, about reading documentation. I felt pretty good about it, but let's look at the code now and talk about it. I think the best place to start is probably right here. So previously, you can see this old main file. This is how the code looked before. It was just all in one massive file here, all done procedurally, no objects or anything using Pygame. And I learned quite quickly that this was not going to be that maintainable or expandable. Pygame is leans toward object-oriented, and honestly, game theory material leads toward objects to allow different types to work differently. So I ended up refactoring that and kind of going into this type of a main file where has some basic things happening. We have the screen being created. This is how Pygame creates screens. Pygame is basically SDL2, which is a graphics library. So XYZ, well, this line actually isn't needed right here. The screen is created and we run the game file, which is where most of the logic is happening. So we'll go there now. And as you can see, this is a massive file. Let's just try to go through. I'm not going to go through everything, but just kind of get a general gist. So here we're initializing the game class and creating a whole bunch of kind of global variables, all public. In general, I'm not the biggest fan of object-oriented dogma and clean code. I don't like private variables. Not the biggest fan of inheritance and things like that. I just think a lot of times it can make things more complicated, but then again, I don't know that much, so I don't worry about private variables with this at all. So everything's public. We have a lot of things being created here. We have the screen width, the screen height. We have the screen itself, which is passed in. We have the state, which is going to come later. We have the clock being created. This is how Pygame, does FPS and things. We have a list for player bullets. We have the player itself, which is a different object. We'll get that later. And just a whole bunch of stuff. How enemies, intervals for how often enemies should shoot, how often enemies should move, how big and wide enemies are. Though some of this code is not relevant anymore. Back when I was using rectangles, this code was more relevant, so I probably need to look at to see if this is even being used at all. It might not be. So yeah, and here are the barrier codes. All this is common. I used to have more barriers, but I decided to remove them. So yeah, you can see here, this is a pretty naive decision for me as to how barriers work. I have each one being created as a barrier, and right now we have like a list here, all barriers, that has every single barrier, but each barrier itself is like its own rect, which is how a lot of things work in Pygame. Rect is how collisions are used. They're just rectangles with X, Y position, width and height. So I have a whole bunch of variables that are being set to barrier classes, which each have functionality, and appending it all into this list. There definitely is a better way to do this. I probably could have done this with a loop or something, but I didn't really go through the mental capacity there of doing that. But this is just declaring a whole bunch of variables. Here we're loading the shape of the player, using Pygame's image.load function, which is how you use your pixel and things. And we're creating a rectangle. That is how we determine where to place an image on the screen and how we do collisions for the image. And we'll get to more to how this works later. And creating the enemy grid, which is another function. So when the game is initiated, all of this is created in this massive initiation file. Then we create the grid enemies, which is, it's pretty simple. We just have the amount of rows we want for the enemy, which was defined in the initialization function. We have the max amount of columns, so it's a 2D array. So we have the columns, the rows of enemies, how many, and the columns determines how many enemies are in each row. And then we just kind of loop through that, create the to list. We define, where we want each enemy to be placed, and we determine this based on each enemy width and the space we want in between them. And then we are setting the amount of points each one counts for. As you know, in Space Invaders, the enemies in the back row go for like 30 or something, and enemies in the middle go for 20, and enemies in the front go for 10. So here we're saying, for at row 0, we're going to say the point value is 30, and the level of the alien is 3. And we use that to determine what image we're going to display. And we're saying it's row 1 or 2. We're going to use point value 20, to the alien value 2, and so on and so forth. And here we're creating the rectangles again, so that we can use these for collisions. Enemy is itself a rectangle, I believe, or okay. Yeah, we're just passing the enemy object, I believe here. I'm not sure why it still says enemy rect, because it's technically just an enemy. But yeah, this, like I said, it's bad code. But anyways, we're appending it to rows, and then we're appending the rows to the entire enemies list. So you have a list of lists, and we set the last row of enemies to be the current enemies that can shoot. Enemies that can shoot is another list. So we set the last row of enemies to be there, and I'll show you how that works later. But now that we've created the enemy grid, we go back up and actually run the code. We'll get to all this garbage later, but here we have our state management. We're setting the amount of lives a player has to 3. And here, this is how games work in Pygame. While the game is running, we're going to set, we're going to do things in the game in an infinite loop, because that's basically how games work. There's an infinite loop, basically like a video playing things over and over again. So here, if the state is a menu, we're going to draw the menu. If the state is playing, we're going to begin the actual game loop. We're going to be checking on every single frame if keys are being pressed, and we're going to check, we're going to update the screen based on what was done, and we're going to draw things to the screen. Then if the game is over, we're going to print the game over screen. If the user said to restart, we're going to restart the game. So let's go over the menu here. The menu is pretty simple, just using the ability to render font in Pygame to print stuff to the screen. And we have rectangles that are placed at where the text is so that users can click the rectangles to determine what they want to do. So the user clicks to quit. The boolean that is telling us to run the game will be set to false, and the game will quit. If the user says to start playing, the game will start playing. If the user presses quit, the game will instantly quit. So that's pretty simple. The playing. So this is where a lot of things get really involved. So let's look at the update function. This is where a mass amount of functionality goes on. So here we are setting the current time of the game to be the amount of text on the clock, which allows us to do a whole bunch of things. This is done in milliseconds in Pygame. Here we're calling the move function of the player class, and I think it's a good idea to just look at how the player class is done. It's very simple. We're just loading the image for the player, getting the rect that the player will need for collisions. We're setting the center of the rect to be the X and Y that is passed in. We're setting another variable here to the actual rect thing here, because we just changed the center, so we need to have another variable that we can actually get the actual rectangle with the correct center, because this is created with, I don't think this is actually created with an X or Y in Pygame, the get rect function from the image, the surface that was loaded. So we set the speed, the lives, the bullets, these are all passed in. And we have the movement here. And movement in Pygame is quite simple, because everything is done in the coordinate plane. The user is pressing the A button, which is normally left. This is going to be easier if I just draw it out, to be honest with you. X Cali draw. So here's how the coordinate plane works in Pygame. Have the top left here being 0, 0. So if we have an element, say at 10, 10 or something, this is not where 10, 10 is, but I'm just saying this for example. I want to move in the leftward direction. Instead of going closer to 0, you're going to need to subtract 10 to get to, say, 5, 5. And if we wanted to move to the right, we need to do, we need to add to the X variable to get it to move in that direction. This is the X, this is the Y. So yeah, that's basically how it works in Pygame. So here we're negating the X in the rectangle and adding to the X to move left and right. Here we are using screen.blit, which is a Pygame function which will allow us to put one surface on top of another. Here we are blitting to the screen, which is our game window. We're blitting the shipped onto the screen, and we're blitting it at the location of the rectangle. So that's why we need the rectangle to determine where to put the actual image itself. And the shooting function is basically appending to our bullets list, which contains all the bullets that are currently being shot with an actual bullet class, which we'll get to later. That's how the player class works. Fairly simple. And here is where a lot of things happen. So we're checking for each enemy if it's alive, then we're going to run the update function in the enemy class. And let's look at the enemy class. Here we are getting all our images for the enemies based on the alien level. That's why we needed that before that was showing you. And we are doing, this is how animation works in Pygame. This is where I kind of made quite a big mistake, in particular with pixel art, what I did not recognize previously, try and show you guys. So this is a sprite sheet, and we have two sprites here. This is just a level 1 alien and his animations. Very simple animation, but what goes into this is that each of these sprites are its own image, and here's split up as a height of 64 and a width of 128. So if we want to get each individual image, we have to split on the 64 here. And when we split on the 64, we would get one of the images and one of the other ones. Now the problem here is that all this padding around the image is still there when we split it up. And if you know anything about how rectangles work in Pygame, the way we determine if two rectangles are colliding is if they are touching each other. So say this is a bullet coming towards this enemy. That's a terrible looking bullet, but we only say they collide when the two of them are touching, like they are in this case. And if they aren't touching, they're colliding. But the problem is the actual enemy image is like right over here. Ignore how bad this looks, but this is where the enemy is, right? And we're saying we're colliding before the actual image has been hit. The actual art itself. So, as human eye, it looks as if they're being hit before it actually touched the enemy. Which, if I actually ran the game here, run the actual game, you can see that happening in real time. You see the enemies are kind of dying before the bullets actually hit them. So this was something I was trying to avoid, but I noticed that the way I had drawn these enemies, it simply wasn't going to be avoidable unless I decided to use something called masking in Pygame, which gets the actual image based on the colors in the image. It ignores all transparency. The masking is also a very slow kind of function to run. You see I have mask actually in here because I was thinking of doing that, but I determined it's just probably not worth it. That code should probably just be removed. But yeah, so what I learned from this is that the next time I draw pixel art, I should use something more to, let's find a good image, something more like this, where I cut out as much padding as possible from the image. And then instead of having like all my animations in one single file, I have them split up like I did with the bullets here. You see we have the first animation for the bullet and the second animation for the bullet kind of split up. So now I just go back and forth between these two images without having to worry about the padding on them. So that was something I had to learn, and it was a good learning experience. Yeah, so basically we create everything for the enemy here. You guys go through all this code. I don't want to go through long here. I'm not like somebody's teacher or something. So, and here we have shooting. We're creating an enemy bullet, which is our bullet class, which is not that hard. It's just going through the animation of the bullets, and it's adding and it's creating a rect for those and changing the speed of the rect and its direction in the enemy bullet class. And the way animation works is we have a list of the images we want to go through. So here you can see I'm appending to that list with the subsurfaces in this case. And then we say based on the time of the time interval here, we're going to say if the time is greater than the interval we want, then we're going to make a change to the current image that we're using, the current animation. And this is done by using modulo with the length of the images. So here we can just constantly go between 0 and 1 because say the current frame was 0, 0 plus 1 is 1. We do the modulo of the length, which is 2. 1 modulo 2 is now going to be 1. And now the current frame was 1. 1 plus 1 would be 2. The modulo of 2 is 0. So we can constantly keep going between 0 and 1. That's how we get animations to work. That's how the enemy animations are working, and the bullet animation. It's kind of hard to see the bullet animation, but they are kind of going back and forth. but that's how we get the enemies also animate. If you want to learn more about this, I would advise you to watch the Fuffly Potato. He's kind of the king of pie game. So yeah, this tutorial right here is great. Talks a lot about all the stuff I'm talking about in this video. Anyways, that's how that works. And here we have collisions with player bullets. So we're just going through the list of player bullets, which is appended during is it during update or is it during? Oh, it's in the main, like what's it called? Run, yeah. Here we're appending using the shoot function of the player to append to the list of bullets, and then basically, we're just going through every single bullet and doing some very tedious but necessary game dev stuff, checking if the rectangle of the bullet is colliding with something else. If the rectangle is colliding with a barrier, remove the current bullet, pop the current barrier list. I'll talk about barriers later. Or if it hits an enemy, remove the enemy, remove the bullet, increase score, decrease the amount of enemies. Yeah, a whole bunch of stuff going on here. If you want to read the code, you can. And we do basically the exact same thing with enemy bullets here as well. Then also, we also do the movement of the enemies. We have a reverse needed boolean here that's checking based on, so as I say here, how many enemies have been killed. Based on the total amount of enemies and the enemy life count, we create a percentage of the amount of enemies killed. And based on that percentage, we create our interval reduction. How the speed range is the constant enemy interval minus the max speed they want to go, and we check we multiply the range by the percent of enemies killed to get the amount in the interval that we need to reduce by. Kind of basic math here. We did fix this actually. And now we can choose to move the enemies, increase the speed of the enemies, and also choose if we need to reverse them. We set reverse need to true when the last column of enemies is at the far left or far right of the screen. Then we reverse the enemies. So yeah, pretty imperative stuff. It is a little bit to think through. It depends on how you do your design, but it is not that hard at the very end. It's just a lot of code to write. Enemy shooting is very similar to moving, and a lot of other things. You'll see this a lot where I'm creating an interval. The interval is just the amount of milliseconds, and based on the current time of the game, which is constantly ticking up amount of milliseconds. In fact, we can actually look at that right now. Current time. So put current time. And you'll see when I run the game, you see that is a constantly ticking up number, and we determine based on this and the last time we actually did something in the game, we determine basically interval whether or not we need to take an action. So here we can set when we want enemies to shoot, how fast we want them to shoot, based on interval. So for example, if I was to create, I was to set our enemy shot interval to like 1,000 or something, which is 1,000 milliseconds. So they'll basically be shooting like once every second. You'll see that enemies begin to shoot very slowly. Yeah, see the enemies are shooting much slower than before because they're waiting almost every second to be shot based on the interval. Now if we set it to something like 100, they'll be shooting every 100 milliseconds, which is like 10 times a second, I think. So yeah, it's gone extremely fast. So you can easily increase the difficulty of the game by using these intervals and using the game clock to determine how fast you want things to go. So yeah, I'll get this back to where it was. So yeah, a lot of that is done in the game, and I think it's pretty common in game development. So yeah, that's how a update function works, and then pretty much everything else here is kind of redundant. And to be honest with you, there's probably a lot better way I could do this. Basically, when I start a new level, I recreate all the constants in the game and rerun the game. Down here, you can say I set self.run back to playing, which would go back to the run function and run the state of the playing again. And then for restarting the game, I also do the same thing. The only difference between restarting the game and starting a new level is that I start a new level and I create the enemy grid. We move the starting Y variable of the enemies down one. At least we should be. I'm not sure if that's done here, if that's done somewhere else. Yeah, I'm having a hard time figuring out where my code is. So here we have self level plus equal to 1. Wait, that's not it. Wait a minute. I might have actually, I think I might have actually removed the code that actually did this properly. Yeah. Oh no, I did not. Okay. If the amount of enemies alive is 0, then we're going to add 1 to the level and start a new level. However, we start new level. Yeah, I think this is actually being done incorrectly. Wait, no, it's not being done correctly. Here we go. I believe, or wait a minute. There is somewhere in this code where we it's redundant. Yeah, I might have to look at this again because I think I made a logic error here. Yeah, there's supposed to be somewhere in the code where we increase, we increase the starting Y so that enemies are further down, but I think I accidentally removed that code. I'm gonna have to look back at this and fix that. So that's how start mode level is supposed to work. I think it's supposed to be like plus self.level times like 10 or something. I think it's supposed to be, that might be somewhere else in the code, but I know for sure that used to be in there. But yeah, bug I need to fix. But that's basically how the game works. Some things I probably could have done better is kind of the state management here. It's not very good. We're kind of running a recursive function here. Every single time we're running like self.run not playing, basically going back to the run function, running the whole entire thing again, doing all the checks again, which is kind of redundant. And in Python, we can actually get a recursion error. I personally have not had run into that yet, but it can happen. That's something I do need to fix. This should be just changing different states within the same game loop, not rerunning the entire game again. So that's probably one of the biggest design decisions. Then also how I restart the game and start a new level. This could be a lot easier if I just moved all this out into another file and changed certain variables, because not all this is changing every single time. Obviously, you can see the code just kind of copy pasted. So yeah, so those are kind of the two big things and that I want to revisit with this game. Also want to get the sound better and just some other polishing touches on the game. But overall, it was a pretty fun project. I definitely learned a lot from it, solved a lot of problems, and had a good amount of fun. But for the next couple of days, or well, for now, I guess we're going to be moving on to kind of more data structure, algorithms, leak code, math, things of that nature as I get prepared for the competitive programming, and then also moving on to the Go course in boot.dev. So yeah, thank you guys for watching. Hope you guys found this somewhat informative or kind of useful, and I will see you all in the next video.